This lesson is largely a review on how to deal with exponents and polynomial functions. So starting with the information in the upper left-hand corner of your screen, says x to the third. So what does x to the third power literally mean? So x to the third literally means x times x times x. So whatever number you have in for x, you would take it times itself 3 times, and that would be your answer. What about x to the fifth? What does it literally mean? It literally means x times itself 5 times. So x to the third times x to the fifth would mean you would have 3x's times 5x's, which would give you a total of 1, 2, 3, 4, 5, 6, 7, 8 x's. So instead of writing all those x's out, we could just take and add the exponents together to get 8. So the rule for multiplying two terms with exponents, as long as they're the same variable, you can see this over here in the upper right-hand corner of your screen, is that if you have two of the same variable and we want to multiply those together, should be a multiplication symbol there. There we go, multiplication symbol. So you have x to the a power times x to the b power. That literally means x to the a plus b power. So that works with any variable. So if you got p to the second times p to the ninth, that would equal whatever 2 plus 9 is. That would be p to the 11th power. And it also works with numbers. If you have 3 to the second power times 3 to the fourth power, we could figure that out by just taking it and calling it 3 to whatever 2 plus 4 is, and that is 6. So 3 to the 6th power. What about the division of variables with exponents? If we've got x to the fifth divided by x to the third, well, we've already said that x to the fifth is the same as x times itself 5 times. And x to the third is x times itself 3 times. And what could happen on this is we could take since it's division, we could take the 3 x's on the bottom and cancel that out with 3 of the x's on the top. And how many x's are left over? Well, you got 2 of them, x times x, which is the same as x squared. So a quick way to do this one, instead of writing out all those x's and canceling it, would be, if you look in the upper right-hand corner, if you have x to some power divided by x to some b power, we could subtract the exponents to get our answer. So b to the 6th divided by b to the 4th, that would be whatever 6 minus 4 is. That's 2, so that would be b to the 2nd power. And we can do that with numbers as well. If we have 9 to the 5th divided by 9 to the 2nd, 5 minus 2 is 3, so this would be the same as 9 to the 3rd power. And I know I'm leaving the numbers with exponents. You could multiply those out if you wish. 9 to the 3rd power literally means 9 times 9 times 9. And that would be 729. The next one is called power of power. It's x to the 5th to the 3rd power. So what does that literally mean? X to the 5th to the 3rd power would mean that you would have x to the 5th power times itself a total of 3 times. Each one of those x to the 5th powers is the same as multiplying it times itself 5 times, so that we'd have x times x times x times x times x, times another 5x's being multiplied together, times another 5x's being multiplied together. And how many total x's is that? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, for a total of 15 x's, or x to the 15th. Well, there's got to be an easier way to do that than write all those x's out. And the easier way is that if you have power of power, and that's what this is called, if you have two exponents sharing the same base, we're going to multiply those exponents together. Notice the difference between that one, this x to the 5th to the 3rd power that's over here, and the first example we did, which was x to the 3rd times x to the 5th. Notice that on the first example we did, and I'm talking up here, right about here, that each of the variables had its own exponent. So we would multiply or add those together to get x to the 8th. But down here, two exponents are sharing the same variable. They're sharing the same base. So that's why we're multiplying, and that's the difference between the two. So d to the second to the fourth power would be whatever 2 times 4 is, since they both are affecting the d. So 2 times 4 is 8, so that would be d to the 8th power. 3 to the third to the second could be rewritten as 3 to the 6th power, because the exponents of 3 times 2 equals 6. And then if you so wished, you could multiply 3 times itself 6 times to get another answer. Not only does power of power work with one variable, it also works with two variables. The next set is xy to the 8th power. Well, we have the exponent 8 affecting both the x and the y in parentheses. What are the variables, or excuse me, what are the exponents on the x and the y? I don't see an exponent written there. Well, those are hidden ones. So that's actually x to the first power and y to the first power. So if you don't see a variable, just like if you don't see a number in front of a variable, it's a 1. If you don't see an exponent with a variable, the exponent is also a 1. Well, then this actually becomes just power of power. So we have x to the first to the 8th power, and 1 times 8 is 8, so that would be x to the 8th. And then we would have y to the first to the 8th power. That would be 1 times 8 again, also y to the 8th power. So if we have two variables being affected by the same exponent outside of parentheses, it's almost like a distributive property where you're distributing the exponent inside the parentheses. Not exactly, but that is sort of what's happening. Okay, it is the exponent outside of parentheses will affect both numbers or terms inside of parentheses. So if we have ab squared to the 3rd power, remember there is a 1 with this a, so we're going to take 1 times 3, which is 3, so that's a to the 3rd power. And b to the second to the 3rd power would be 2 times 3, which would be to the 6th power, so that would be b to the 6th power. This one, the 2 gets affected by the 4, so that's 2 to the 4th power. K is also affected by the 4, so that would be k to the 4th power. Now that 2 to the 4th power looks a little strange, so I'm going to go ahead and take 2 times itself 4 times. So 2 times 2 would be 4, times the next 2 would be 8, times the next 2 would be 16. So 2 to the 4th power is 16 k to the 4th power. Notice that the 16 is not the same as if you would take 2 times 4. Remember, the 2 is a whole number. It's a base. It's not an exponent. We're still going to just take 2 to the 4th power like you did probably in junior high school. Take 2 times itself 4 times. But the k to the first to the 4th power, those exponents get multiplied because they're both exponents. This rule also works with fractions as well. So if you have x to the 2nd over y to the 3rd, everything is going to be affected by that 4th power. So we're going to multiply the exponents, so that would be x to the 8th over y to the 12th. So just like we've seen so far, if it's two terms being multiplied in parentheses, if it's two terms being divided in parentheses, both of those terms are going to be affected by the exponent. So x over y to the 2nd is the same as x squared over y squared, because, again, both of those have exponents of 1, and 1 times 2 is 2. And then we have a over b to the negative 5 power. Well, how in the world do we deal with negative exponents? So we're going to put that one on hold for just a little bit and talk about how to deal with the negative exponent. If we have x to the negative 3rd power, so I'm back down to here. If we have x to the negative 3rd power, the negative exponent is our reciprocal exponent. So I'm going to write that in here. Negative exponents are the reciprocal exponents. And reciprocals means exponent. Spell that out, Mr. Carter. Exponent. There we go. The reciprocal exponent means we're going to move it to the other part of a fraction. So if it's x to the negative 3rd, we're going to put that on bottom of a fraction. And when you move it, you change it to a positive exponent. You should always do that because we should not leave negative exponents in the answers. So no negative exponents in the answers. If you do that, it would be counted wrong. Well, what if it's in the bottom of a fraction and already a negative exponent? Well, that means we're going to move it to the top. So this would be 1 times x to the positive 4, which is just x to the positive 4. So again, there's kind of two separate rules on this one, but they're both related to each other. X to the negative a power, we would move that to the bottom of a fraction. But if there is a negative exponent already on the bottom of a fraction, it'd get moved to the top of a fraction. So 3 to the negative 5th power would be, moving that to the bottom of a fraction, 1 over 3 to the positive 5th power. And then you can choose to multiply that if you wish. 1 over b to the negative 7 power, well, we have a negative exponent already on the bottom of a fraction, so I'm going to move that to the top. So that would be b to the 7th over 1, because you got to have something on a fraction, or just b to the 7th. So back up to this problem, a, b to the negative 5th. So both of those are going to have the negative 5 affecting them. So that would be a to the negative 5 power over b to the negative 5 power. And since I shouldn't leave negative exponents in my answer, I'm going to move the b to the negative 5 power to the top and make it positive, and then the a to the negative 5 power to the bottom and make it positive. So the final answer is b to the 5th over a to the 5th. But remember, do not leave negative exponents in your solution. And then finally, the last one, x to the 0 power. What does x to the 0 power equal? So many people think x to the 0 power equals 0. It does not equal 0. X to the 0 power actually equals 1. As a matter of fact, that's true for any number to the 0 power. It always equals 1. Well, how in the world is that possible? What's the reasoning behind taking a number or variable to the 0 power and calling it 1? And the reason is it has to work with the division rule as well. So let's say we had, x to the 4th divided by x to the 4th. So back here, according to our division rule, when you divide exponents, you subtract the exponents. So you would have 5 minus 3 up here equals x to the 2nd. Well, if I do that on this one, I would have x to the 4th over x to the 4th. According to the division rule, I should subtract 4 minus 4, which would leave me x to the 0 power. But probably as far back as elementary school, you learned something about dividing a number by itself. What does a number divided by itself equal? Well, a number divided by itself equals 1. So if we subtract the exponents to get x to the 0 power, but dividing a number by itself gives you 1, it stands to reason that x to the 0 power must equal 1. So that's where that rule comes from. So any variable to the 0 power is going to equal 1. So b to the 0 power, what's it equal? Well, it equals 1. 7 to the 0 power, what's it equal? It equals 1. 247 to the 0 power, what's it equal? It equals 1. It doesn't matter how big or how small it is, it's always going to equal 1. So right here is a summary of all the exponential rules that we just discussed. This is in your textbook in section 4.1.